Today we're going to be graphing inequalities in two variables. Inequalities are things like less thans, greater thans, less than or equals to, greater thans or equals to's, things that don't have the actual just equal sign by themselves. But before we graph inequalities, I want to graph one equation, one thing that has an equal sign. This is in slope-intercept form, y equals mx plus b. This right here is the y-intercept, meaning where the graph is going to start on the y-axis. It starts at 4. This is your slope, and remember slope is rise over run, so I'm going to rise 2, I'm going to go up 2, I'm going to run 3, I'm going to go to the right 3. So from this point here, I go up to right 3, and I can also go down to left 3, down to left 3. Excuse me. The graph will look like this. Slopes and y-intercepts. Well, the nice thing about this is graphing inequalities is essentially no different. There's just one or two little things to worry about, but they're fairly straightforward. Even though this has an less than or equal to instead of an equal to, nothing changes. This is still my y-intercept. This is still my slope, up to right 3 or down to left 3, down to left 3. And the graph is just going to be the same old graph, but we have to remember now the y values, meaning the stuff going up and down, the stuff on the y-axis, the y values have to be less than or equal to 2/3 x plus 4, which means everything below this line can also work. And there's this huge range of points that could also work. So I shade. I grab my crayon and I shade the areas that are possible. What this means is if I picked any point at all in this shaded region, like this is the point 2, 3. This is the point 2, 3. The point 2, 3 should work in this inequality up here. So I'm going to just plug that in and check it. I plug in 3 for y, and we'll see if that's less than or equal to 2/3 times 2 plus 4, because I plug in 2 for x. Is 3 less than or equal to 4/3 plus 4? Well, yeah, 4/3 plus 4 is 5 1/3. 3 is less than or equal to 5 1/3, so it works. And if I were you, I would be smart about the points that you pick to check. I should have picked a point like 3, 1 or 6, 4, something where the x value is a multiple of 3, so that I wouldn't have to deal with these fractions. But because this was a less than or equal to, I shaded below. Had it been a greater than or equal to, I would have shaded above. This is going to be, again, almost the exact same thing, this third inequality, except for it doesn't have the equals to on the bottom like this one did. It's missing the equals to, and that changes just one thing. The graphing still looks the same. Start at 4, up to right 3, down to left 3, down to left 3. But this time my line is not solid, it's dotted. We use a dotted line to show that the graph can't actually equal the line itself because it doesn't have the equals to underneath. So when you have a less than or a greater than that doesn't have the equals to, you use a dotted line. And there's me graphing this inequality. I like this because I get to use my crayon. So I'll just do a couple more examples and that should take care of it. This time we have a greater than. When you have a greater than, instead of graphing below, you graph above. So this is going to have a dotted line, and it's going to graph above. My y-intercept is -2. My slope is 1/4, up 1, right 4, up 1, right 4, which would be here, and down 1, left 4, down 1, left 4, which would be slightly off screen. Dotted line, I'm going to make this blue. Looks like that. It says greater than, so I shade above. All this stuff up here. Now I'm going to check to make sure that this works. I can pick any point in the shaded region. And I want to make something really clear right now. If I were to pick a point that was actually on the line, like say I picked the point 4, -1. What should happen is when you pick a point on the line, when you plug stuff in, this side should come out the same as this side. They should come out to the same number. If you pick a point on the line, they should come out to the same number. So this is the point 4, -1, so I'll have -1 is greater than 1/4 times 4 minus 2. So -1 is greater than 1 minus 2. It says -1 is greater than -1. Well, that's not actually true. -1 is not greater than -1. It's the same, but not greater than. But it wasn't supposed to be true because it was on the dotted line. And things on the dotted line aren't actually supposed to work. So that's a good check. Now we'll also pick some other point to make sure the points do work. Here's the point 0, 0. Plugging in 0, 0 is really easy. We get 0 is greater than 1/4 times 0 minus 2, which says that 0 is greater than -2, which is true because I would rather have $0 than owe somebody $2. So that works. This last one is not in standard form. It's in standard form, not slope-intercept form. You can graph it using our same tricks as before. With standard form, you know you have ax plus by equals c, and we know that the slope is -a over b, which would be -5 over -2. We know the x-intercept is c over a, which is 10 over 5, which is 2. The y-intercept is c over b, which is 10 over -2, which is -5. So we're going to have an x-intercept at 2, a y-intercept at -5, go up 5, right 2, up 5, right 2. And then I'm going to graph this. It's going to have a solid line because it's got the equals 2 underneath. But now I want you to see something and watch this very closely. When I graph this, right now it looks like I should be shading above because it has a greater than. So I'm going to shade above, but that's actually going to be incorrect, and you'll see why in a second. Let's check this. I'll pick the point 0, 0 again because it's easy. You can always plug in the point 0, 0 to see if it works. Here's the point 0, 0. I'm going to see if that point in my shaded region works. If I plug in 0 for x, I get 0 minus 0. That was weird. 0 minus 0 is greater than or equal to 10. 0 is not greater than or equal to 10. It doesn't work. So when I say that if you have a greater than, you should graph above, and if you have a less than, you should graph below, that only works if the y is by itself. Only works if y is by itself. So either you always get y by itself first, which most of you will do anyways because you like slope-intercept form, or 2, you just have to check to see which side to shade. Here's how I recommend you check. Plug in the point 0, 0. If the point 0, 0, which was here, if that point works, great, shade that side of the line. But if that point doesn't work, like it did in this case, shade the other side of the line. Just plug in a point. If the point works, shade that side. If it doesn't, shade the other side. And let me show why this happened. Here's, and maybe you've already kind of caught on to this, but if we were to solve this, 5x minus 2y is greater than or equal to 10. A smaller pen. If we were to actually solve this for y, we would subtract a 5x from both sides and get -2y greater than or equal to -5x plus 10. Then we would divide everything by -2. And in the process of dividing by -2, the inequality would flip. We would get y is less than or equal to 5 over 2x minus 5. When you divide by a negative number with inequalities, the direction the arrow is pointing, the direction the inequality is pointing flips, And that's why what we thought was supposed to shade above actually shades below. So either always get the y by itself and then graph, or just check to see which side you're supposed to shade. A lot of people prefer the second option because it's pretty simple to plug in 0, 0 and see which point works or doesn't. So here's a quick little recap. When you have y is greater than mx plus b, that'll be a dashed line and you'll shade above. If it's y is greater than or equal to mx plus b, it'll be a solid line and you'll shade above. If you have y is less than mx plus b, it's a dashed line and you shade below. If it's less than or equal to mx plus b, it's a solid line and you shade below. These four I didn't show in the work, but I'll just cover them real quick. If you have a vertical line, don't shade above or below, shade left or right. So this means shade to the right, this means shade to the left. If you have a perfectly horizontal line, like y is greater than a or y is less than a, then you shade above or you shade below. Thank you, hope you have a nice day.